In today's video, let us see how to solve this probability question using tree diagrams. So there are 3 tiles, 2 A's and 1 B, and we are selecting twice. Both the times we are choosing one tile and then replacing it. That is the key here. We have to draw a tree diagram to show the probabilities. So let us see what a tree diagram looks like. Since we are selecting twice, let us first mention that we start from this node and we mention the options. It's A or B. Let me put it a little down so that it's easy for me to expand for the second one. So this line is the branch and at the end of it we write the option. Totally there are 3 tiles. The A's are 2. The B is 1. So probability is a fraction with the numerator making up what is of our interest and the denominator being the total or the sample space. So obviously 2 of 3 should be A. The sum of probabilities at any point always add up to 1, leaving B with 1 by 3, and B is indeed 1 by 3 because of the 3 tiles 1 is only B. This is the first selection. Now the second selection, again we return it, so nothing is going to change. Again, it could be an A or a B. A or a B with the same probability. So if you see, it starts here and expands along the branches. As the branches keep going, it gives us a look and feel of a tree. That's why it's called a tree diagram. This is answer to part A. Let us see how to do part B. We need to work out the probability that at least one A is chosen. So at least one A. This is the keyword here. Let us see what all combinations make up this particular criteria. First time A, second time B, or first time B, second time A. And since it's at least, it means it can be more than once. You end up taking A's both the times. So probability of at least one A should be, all we need to do is choose the branch for that particular combination and multiply the probabilities along those. So A, B, B, A, A. So an AND in probability is represented by a multiplication operator into, and an OR is by a plus addition. So either this or this or this. So for A, B, 2 by 3 into 1 by 3, or which means plus, first it is 1 by 3 and then 2 by 3, or both the times it is 2 by 3. So 2 by 9 plus a 2 by 9 plus a 4 by 9, which is 8 by 9. There is another way also to do it using the negation method. As we all know, sum of probabilities is always 1. So probability of something happening plus probability of something not happening should always be 1. So since they have asked at least one A, what is the opposite of that? You don't take any A's at all, which means probability of both being B, which is just this. It's 1 by 3 to 1 by 3, which is a 1 by 9. Since we got probability of both E, what we need is the opposite of this. So they both should essentially add up to 1. So probability of at least 1a should be 1 minus both being b, which is again 8 by 9. So we see that the result in both remains the same. This is method 1. This is method 2. Method 2 is ideal in cases of at least. So depending on the scenario, wherever can be used. This is more easier and quicker. You just find the opposite of it and subtract it from 1. You get the answer. So I hope that was clear. I will see you all in another video. Thank you.